Hello students, fixed biasing circuit is, so this is also called as base biasing circuit. This is also called as base biasing circuit. Base biasing circuit. The circuit diagram will follow like this. A transistor with, let us take a transistor of NPN transistor, where we have the collector will be having collector resistance, base will have its own base resistance, okay. This will be got grounded. This is the base resistance and this will be the collector voltage, and the voltage appearing at this point is base to emitter voltage. What do you mean by VCC? VCC is the collector voltage. VCC is the collector supply. VCC is the collector supply, and it provides the necessary biasing voltage and currents. It provides the necessary biasing voltage, and currents. Okay. Now this RB is connected to provide a necessary base voltage, and RB is also used to limit the base currents. Okay. So the base currents is this way. This is the base current IB. So this circuit is also represented in this way, is the collector voltage which provides the necessary base biasing voltage. So this can also be split in this way. Okay. So let us split this collector voltage as VCC, and this is also VCC. This is the ground, right? Let us consider this positive. Let us extend this positive. Let us take this ground. Ground is a huge potential of negative potential. Let us consider this ground to this here. So I can erase this ground right now. So these two are connected now. Now here it forms the input side, whereas this collector voltage can be split into this way. So this is the another positive potential. This plus and the minus will be connected like this. Okay. Now this forms the input loop. This is I1 input, and this forms the output. So this is the collector current, this is the base current. Okay, this is the emitter current. I hope this point is clear to everyone. So this is nothing but the VCC. Okay, this will be VCE. This will be RB. This is RC. Now let us apply the input loop. In this, let us apply KVL here. KVL in input loop. If you apply KVL in the input loop, what we can see here? So it is starting from this part, no? So this will be plus VCC, or else you can apply like this, no? Then we get minus VCC plus IB into RB plus what is the voltage we can apply observe here? VBE. Yes or no? VBE plus VBE equal to 0. Sum of all the voltage drops in a loop is equal to 0. Then this can also be written as VCC is equal to IB into RB plus VBE. Okay. Now what we can write here? We can also split this into two parts. We can also manipulate this as IB is equal to what? We require to find the value of IB. Then IB into RB is equal to what? VCC minus VBE. Then what is the value of IB? IB is equal to VCC minus VBE upon RB. So what do you mean by VBE? VBE is the base to emitter voltage, this value, base to emitter voltage. So this VBE is equal to 0.7 volt for silicon and 0.2 volt for germanium. Okay. Then RB is nothing but the base resistance. And what do you mean by VCC? VCC is the constant voltage. It won't change. Constant voltage. IB is the fixed current. Now this is the reason why it is called fixed bias. Unless or until it is changed, it is fixed. Fixed current or base current. Fixed current, or we can also call as base current. Okay. So this is the IB value. In the same way, we can even find the value in the output side. Yes or no? If you observe this equation in this loop, here apply KVL here, then what we get here? This is VCC. Then what do we get from this equation? VCC plus this will be minus VCC, right? Voltage drop minus VCC plus IC into RC plus VCE is equal to 0, because sum of all the voltage drops in a loop is equal to 0. That implies VCC is equal to IC into RC plus VCE. Okay. Yes or no? So RC is selected such a way that VCE is equal to VCC by 2, because we have splitted this voltage VCC into two categories. No, split into two parts. Plus VCC by 2, one half, other half. So due to this, operating point at the center of the load line will shift. Okay. RC also acts as a load in the amplifier. Okay. So if you observe here, we know that IC is equal to what? Beta into IB. What is the value of IB? You substitute over here. Beta into what is the value of IB? Is VCC minus VBE by RB. Okay, this is the value of IC. So let us take this as equation number 1. This will be 2. Okay, substitute the value of this IC in this equation. Let us name this equation number 3. Let us name this equation number 3. So what is the value of IC? IC is equal to this value. Substitute over here. So what do we get here? That implies VCC is equal to IC is what? Nothing but this value, beta into VCC minus VBE by RB into RC plus VCE plus VCE. What is this IC and VCC? IC, IC is nothing but the output current, and what is VCC? VCC is the output voltage. Okay, no, not this VCC, VCE. From this we can find a value of VCE, right? By finding this VCE, this is the output voltage. Okay, so collector junction gets reverse biased when VC greater than VB. So transistor will be operates in active region. So as emitter is grounded, as emitter is grounded, then voltage across the emitter will be 0. Then base voltage VB will be positive. We know that VB is equal to VCC minus IB into RB. Then collector voltage will be, then what is collector voltage? Collector voltage is nothing but VCC minus IC into RC. Okay, then collector junction gets reverse biased. Collector junction gets reverse biased when VC greater than VB. When VC greater than VB, transistor operates in active region. Transistor operates in active region. Okay. Fixed bias circuit, stability factor equals to what? 1 plus beta. Stability factor will be equals to what? 1 plus beta. So IC remains unstable. So the drawback will be here is, you have to remember this drawback. IC remain unstable. IC remains unstable. Okay, this is the drawback.